Hi everyone, this video is on questions 1 and 2 from exercise 9H of PO2. So this section is about implicit differentiation, which is an interesting technique that we are going to learn in this section. And in these two questions, we are asked to prove two fundamental results that are constantly used in implicit differentiation. And from the next questions, which will be in the future videos, I will be solving actual examples. But in this one, I just want to show how what are the results, and then in the future videos we are going to use them. So for the first one, which is question 1, we have the function u, which is equal to y to the power of n, and we want to use the chain rule to show that d dx y to the power of n, which is something that we we are not used to because we have a function of y, but the we are differentiating that with respect to x, which is something we don't do because normally we have a function in terms of x and we differentiate that with respect to x, for instance. But this time it's in terms of y and we are differentiating with respect to x rather than y. And now we want to see how can we do that basically. Okay, we want to use the chain rule. So for the first thing, let's find the u dy. So that's n times y to the power of n minus 1. This is just the usual differentiation. And so here the objective is starting from the left hand side and get to the right hand side. That's usually how we do proofs, that we choose one side and we try to get to the other side. So in this case, we are going to start with the left hand side. So in the left hand side, we have d dx of y to the power of n, and note that we are told that y is equal to u is equal to y to the power of n. So we can just rewrite this as d dx, du dx basically, right? Because y to the power of n is just equal to u. Okay. And on the other hand, we, from chain rule, we know that du dx is equal to dy dx times du dy. So this is just the standard chain rule. Okay, now if you look at the question, we have du dx, right? Because du dx is basically sorry, I meant we have du dy. So this is du dy, right? We can substitute that into here, and we don't have dy dx obviously, but that's fine. And we have the u dx as well. So we also have this one because the u dx is equal to d y to the power of n over dx. And we also have the u dy as I mentioned above, because that's just here. So we don't have dy dx, and that's fine because if we substitute the ones that we know, we are going to get exactly what we are asked. So now it's the substitution time. So we know that the u dx is equal to d times y to the dyn is equal to dx, and the u dy is equal to n times y to the power of n minus 1 and times dx dy. Sorry, dy dx. And yeah, so that's exactly what we wanted to show. d dx y to the power of n is equal to n times y to the power of n minus 1 divided by dy dx. So that's for this one. Okay, now let's do the second one, the second question. So the second question is that use the product rule to show that d dx xy is equal to x divided dx plus y. Okay, this one is very quick. So we use the product rule, and based on the product rule, we know that we differentiate one function, and that is being multiplied by the other function. And then the second step is just the second function differentiated times the first function. So to use that, basically what we do here is that we can start by doing dx of x times y. So what I did here was that I basically applied the differentiation to the first function and then multiply that by the second one, which is y. And for the next one, I'm going to do the opposite. So I will apply the differentiation to the second function and keep and multiply by the first one. So like this, dy dx times x. And now we can simplify this one because we have dx over dx, which is just 1, right? So we get 1 times y plus, here doesn't change, x dy dx. And that's exactly what we wanted to show, because we wanted to show that we get x dy dx plus y. So here's x dy dx and here's y. I can just write y instead of y times y. And yeah, so that's it for the second one. Okay, so that's it for this video, and in the next videos we are going to use these results to solve some examples. Thank you for watching.